All right, this video is going to go over inverse trig. It's not that difficult once you get the hang of it, but I will say you really need to know this right here. And what this right here is it's telling you the range of these like arcsine functions, for example. And so basically what happened was, if you think about the sine function looks like this, right? And then it keeps going. Well, they want to do the inverse of this. And so, like, if you did the inverse of this as it was, you wouldn't have a function. It doesn't pass the vertical line test. So what they did was they made cuts on the sine function here and here at negative pi over 2 and at pi over 2. That way it restricted it to just this section of line, so that when they turned it vertical for the inverse, it looked something like this. And now it is a function. And so what that did was it changed the range of this arcsine, for example, function to be pi over 2 and negative pi over 2. So essentially what this means is anytime you have an arcsine function, your answer could not be something like pi, for example, because your answer must be between negative pi over 2 and pi over 2. So really, you can kind of think of it like this. If it's positive, if they're giving you inverse trig of a positive, it's going to be whatever the reference angle is, whatever quadrant 1 angle is. But if it's negative, like this one, you're going to have to think what the negative reference angle is. Or if it's like a negative cosine, your answer is going to be what the reference angle would be in quadrant 2. So let's just look at some examples. I know that was kind of confusing, but that's kind of the background for inverse trig. All right, so arcsine of 1/2. The reference angle that throws you a sine of 1/2 is pi over 6. So since this one's positive, we just answer what that would be in quadrant 1, which would be pi over 6. Now, the second one, where it's negative 1/2, arcsine of negative 1/2, you still talk about the reference angle being pi over 6. But now you have to answer where it would be in quadrant 4. And these angles are all just negative reference angles. So my answer here would be negative pi over 6. I know that was kind of confusing. Arc cosine of 1/2. Since it's positive, it's going to be in quadrant 1. It's going to be here. So you just say what the reference angle is, which is pi over 3. And where that would be in quadrant 1 is just pi over 3. Now look at this next one. Arc cosine of negative 1/2. Well, the reference angle is still pi over 3. But now I have to answer where that's going to be in quadrant 2. The over 3 angle that's in quadrant 2 is 2 pi over 3. It's like here, 2 pi over 3. All right, moving right along. Arctan of root 3. First of all, it's a positive, so it's going to be whatever the quadrant 1 angle is, which is nice. I would make this over 1 and then write y over x next to it. So the coordinate that gives this is going to have a 1 in the numerator for the x and a root 3 in the numerator for the y. It's going to look something like this. So that's pi over 3. So this one's reference angle is pi over 3. And since it's positive, it's just in quadrant 1. So my answer here is just pi over 3. But like now when it's negative, it's going to be wherever in quadrant 4 this angle is. So basically the negative version of the reference. So if my reference is pi over 3, my answer is just negative pi over 3. It's like right here. All right, arcsecant of negative 2 over root 3. Don't let the oppos confuse you. Just call it arc cosine and flip it. And follow the same pattern. So my reference angle here is pi over 6. But since my arc cosine is of a negative here, it's going to be whatever that is in quadrant 2. So in quadrant 2, that's 5 pi over 6. All right, same thing for the arc cosecant. Just call it arc sine and flip it. So if this is -2/1, call it arc sine of -1/2. Now go get your reference angle. That's pi over 6. But since it's a arc sine of a negative, it's going to be here in quadrant 4. So it's basically the negative version of the reference angle, negative pi over 6. And then lastly, we have a couple quadrantals. So a quadrantal is when it lands like on an axis like this. Arc sine of 1. Basically, they're giving you a coordinate, 0, 1. So that's up here. And that's just at pi over 2. And if you remember, pi over 2 and negative pi over 2 are included, so they can be your answers. So this one's just pi over 2. Arc cotan of 0. First of all, call it 0 over 1, and cotan is x over y. So they're basically giving you a coordinate 0, 1. So that's up here. Same spot as last time, actually. So my answer here is pi over 2. So just one more example I just thought of. What if it was like arc sine of -1? I feel like this is the one that gets everybody. Well, you just have your coordinate 0, -1. They're basically giving you the y value. So 0, -1 is here. And so your answer is just going to be negative pi over 2. Not 3 pi over 2, for example. So follow the range of your arc function. And as long as you obey those rules right there, you're going to be fine. So if I was taking a quiz or a test on this, I would definitely draw this right here in order to do better. Hope this video wasn't too confusing, and I hope it helped.